We have section 7.1, question E2, and we're getting into the sampling distributions here in this chapter, which are a little bit odd at first, I guess, to think about. So this is the type of histogram we're used to. In other words, each part of this histogram represents a single student who took an exam. We might look at this bar right here over between 35 and 40 points and see that about 5 students scored within that range. So what the sampling distribution is we're taking a certain size sample out of our original distribution, and then we're getting some statistics, such as the mean, for example, in this case, and then plotting the mean. Then we're taking another sample, random sample, and getting the mean of that and plotting that, and another one. So both of these are distributions of the sample mean. However, they clearly look different. So the first thing we're asked is, which of these would most likely be 100 random samples of 4 students, and which would be 100 random samples of 30 students? Now, we couldn't tell directly, but we certainly can compare the two of them. And the first thing you might think is, well, looks like there were a lot more taken in this one. This one, not so much. But that's not really true. These are relative frequency histograms, which means realistically the height of these bars, if we were going to do a frequency histogram, would probably be much higher than the heights of these bars. So that doesn't really tell us much. What we can notice is that the spread is much smaller in this one. In other words, almost all the data points here between 70 and 82, whereas here they spread out much wider. So what's going to happen is the larger sample we take, the more we're going to know, we're going to have a better estimate of where the actual population mean is. If we just take a couple samples, maybe we get 3 of them from over here and 2 here, so it gives us a really high sample. Or maybe we get a few down here and 1 in the middle, so we get a really low sample. So if we just take samples of small size, I shouldn't say a few samples. If we just take samples of small size, it's easy to get values that are pretty extreme, like what we see right here. Whereas if we take larger samples, so we're taking 30 students from this, and then taking the mean of all those, that will be pretty good approximation of the actual population mean. And so looking at these two, I can tell that this figure 1 has samples of much fewer students than this one because the spread is so wide. That tells me it's not a good thing. You can think about the spread being kind of a bad thing because we want to predict where our actual population mean is, and this gives us a much more accurate reading that the mean is probably 77, something like that, 74 to 77. Whereas here, it's really hard to tell where the population mean is. So this is a random samples of 30 students, and this one is 4 students. Now the second hour class of the statistics had an average of 86, and the instructor says this is just a random assortment. So if we look at these two, and we look where an 86 might fall, here an 86 would be over here, which would be feasible. It's certainly part of the data set anyway. Here an 86 would be right at the edge of this tiny little portion here. So if we got an 86 on this distribution, I'd be very concerned, whereas this one, maybe not so much. So which one do we pay attention to here? Well, we want to know the greater number of students per sample is going to give us the more accurate estimate of where the population mean is. So this is what we want to look at. We always want to look where the sample sizes are highest. So this is figure 2. So looking at figure 2, we think the mean is probably between 74 and 77 or 78, I guess. This is every 4, so 78. So if we're getting 86, and it's not just a single student, that could be very likely, looking at here the original distribution. But we're looking at a class of 30 students. So when we get 30 students out of this original distribution, we should be getting pretty close to the population mean. And so if we're getting an 86, that tells us that these students are not like the typical students in the population. It tells us there's some difference. Maybe these students somehow chose the class because of the teacher or because of the time of day, but whatever, these students tend to be on average better than the typical statistical students at University of Florida.